colon, and
yeah, so string colon is just, basically what you're saying is find needs to return something to you that says, I didn't find it, right? It could return to you 0, 1, 2, 3, all these indices. It actually needs to return to you in this, it uses a special sentinel value that says, I didn't find it. And you might think that might be -1 or some other thing, right? A good programming form, though, would be to have a constant for it, right? So that you don't have any magic numbers embedded in your code. And that constant is defined as part of the string class. And so that just the syntax for accessing that constant out of the string class is using the string class name : npos. So it's basically the syntax for, I have a constant that was defined within a class. How do I get to it? I use its class name, 2 colons, and then the name of the constant. And it's just C++ for something that in Java looks a little bit more like class name dot. Question?
Sometimes I see a function declaration before name and then the definition afterwards. Is that just a matter of preference?
It totally is, right? So partly I'm being a little bit lazy in class, right? Which is, if I put the function definition up here, then I can call it down here because it's already been seen. If I put it down here, then I need a prototype up there. And then the prototype means I have to be a little bit more careful. When I change the name, I got to change it in both places. If I change the arguments, got to change it in both places. But the problem, of course, is that when you read the code, it probably reads a little better to say, here's the main, which makes calls to A, B, and C, and have A, B, and C down here. And so some of it has to do with, well, it's a little bit harder to maintain in that form, but I think it's easier when you're done to read it. And so you're totally free to do it either way. You probably just ought to pick a strategy and go with it. That the maintain the prototypes is not really that much work once you get used to it. And I think in the end, it probably is a little bit cleaner. But when I'm being lazy in class, I'm much more likely to just throw them up there to save myself some time. That's a very good question, though, because it's good to note. There's a lot of things that probably will slip by me if I'm not being careful, and you want to be sure to call me on it if I'm not giving you the right information. So let me go back and pick up. There's a few last little details about string that I don't want to overlook before I move away from this. So that there are this library of functions, and I say need to know, right? I have them kind of sketched out in a couple places, and that you can kind of look at them and see what they do, kind of knowing they're there, and then learning about them as you encounter them is a fine strategy. There are a couple additions in our stir-utils, which is a 106 specific header file, which are just some things that, for one reason or another, are a little bit harder or more annoying to do using the standard tools than we think is worth putting on your plate for now. And so we have two convert to upper and lower case that, given a string, just convert it to its upper and lowercase equivalent. And some things that do conversions between string and integer and real, and between string and integer and string and real when you have it in one form and you need it in the other. Here's something that just does that for you as part of the string library. So just some simple things that you might find yourself needing, and you just want to know they're there. So here's something that actually is a little bit of a bummer. Part of the legacy, right, of C++ being built on C means that every now and then there's a little bit of the history, kind of in our deep, dark past, that pops its head up in ways that are a little bit surprising. And for string, it turns out there is a little bit of a weirdness here that I want to point out before you run into it the hard way. That there is a notion of the old style C string. So the original C language didn't have a string class. It actually doesn't have any object-oriented features at all. And it did have, though, some other more primitive handling of sequences of characters, because this is a very common need, right, is to have something. Now, I put in parentheses what it actually is. It's a pointer to a character array that's an alternative. Don't worry about what that phrase means if it doesn't mean anything to you, but that's just for those of you who've seen it a little bit before, I'm just reinforcing that, yeah, we're talking about the same thing. That would be fine. We have this better string object that has all these fancy features, so you'd think we could just use that and ignore the fact that the other one is there. It almost, 99% of the time, that's exactly how it's going to work. But it does turn out that there are a few situations where this old style string kind of pops its head up and gets a little bit in our way. One way that may be a little bit of a surprise is that the string literals are actually C strings. That when you see an open quote, some characters, and then a close quote, that the compiler interprets that as a C-style string. Okay. It also, though, has a mechanism by which if you tried to use it in a context where you needed a C++ string, it will just automatically convert it for you. So it'll take the old style string and make a C++ string out of it. So, okay, so that means that basically I can just use them wherever I wanted, and it seems like it'll mostly work out. There is a way you can deliberately force it. If you use what looks like the typecast here, this is actually calling the string constructor, and you pass a string literal or string constant. It'll turn it into a C++ string manually there. Okay, and then well, it's going to turn out that you might need to know this, right? And then there's also the other problem of, well, what if I have it in one form, I want it in the old form? So this is, I have the old form, I want a new form. I have the new form, I want an old form. There is a member function on the string class that will return to you an old style string from a new style C++ string, and it's called the C_stir routine. Okay, so they let you convert. Why do you care? Well, it turns out there's one thing you'll definitely run into, which is when you're opening a file, this will come up probably not today, but certainly on Wednesday. You're opening up a file stream and you want to say this is the file on disk that you want to identify. It turns out that that library requires the use of a C string as the name. It's just kind of a part. There was a little bit of an issue trying to get all the libraries to come together at the right time. And it turns out the stream library got finalized before the string library was done, and so it depended on what was available at the time, which was the old style string. And so even years later, when they're both happily, debugged and working and everything, it is still the case that when you use the stream library, you're trying to open a file, you have to describe the file you want by using the old style string. So if you had a C++ string variable that held the name you wanted, you'll actually have to convert it. Converting in the other direction comes up pretty much in one case, and I'm going to show you this one. It has to do with concatenation, that the plus operator that does concatenation really wants to work on C++ style strings. So if one of your operands is a C++ string, it's all fine. As long as the left or the right side is a C++ string, it's good. Then the other side can be a string literal, a constant, another string, a character variable. All those things work fine. So as long as at least one of the operands really is a true C++ string already, you're good. That's almost always the case. But in the case where you somehow have two things on either side of the plus, neither of which is already a C++ string. So typically that means you have a C string on one or both sides, a character on one or both sides. You are not going to get concatenation. If you try to add two C-style strings, right, it actually won't compile. Thank goodness, because that'll help alert you to the problem. The sad thing about these two things, about taking a string literal and adding either a character constant or a character variable, is that it does compile and it just does not do what you want at all. And it does so in kind of a silent but deadly sort of way. I'm not going to tell you really what it does, but if you are curious, you can come and talk to me and I'll lay it out for you. But what I want you to come away with, right, is just this memory that when I'm using concatenation, that to be sure that one of the two operands is a string, a C++ string, if you have to, force one, right? If you have a string literal and you want it to be a C++ string, then make it one to avoid running into this. Because the mistake that you get from this is actually quite mystical and very confusing. I'd like to say, really, probably 95% of you would never run into this, and so mostly I've just confused you for reasons that seem kind of unclear. But for the 5% that we're going to run into this and then not have any idea where it came from, I'm really trying to do you a favor by giving you a heads up before it causes you a lot of grief later. So just kind of a little bit of a legacy, right? C and C++, right, kind of go back a long way, and as a result, sometimes we have these little quirks we have to deal with even in the modern world.
Is that the only way you can convert a C string into a C++ string?
Not exactly. I mean, a lot of times it just happens automatically is the truth. In almost all situations, like if you had a routine that expected a string argument and you passed it a string literal, it will automatically convert. So mostly you won't need to do this is the truth, right? So it happens all the time behind the scenes without any effort on your part. But this is the official way to say, I've got a string right now, and I really want to force it, and I'm not waiting for the compiler to do it on my behalf. I need to, in particular, for example, in a situation like this, it doesn't realize what you really wanted to do was convert this and do concatenation. It does something kind of goofy based on what the old meaning of taking a C string and adding a character to it was, which was not concatenation. Okay. So that's just a little moment of silence for sort of an old language C that comes back to haunt us a little bit like a ghost in the attic. All right, so let me tell you, way in the back.
What exactly do you mean by a string literal?
So a string literal just means a string constant. It just means something in quotes.
Okay,
so
without explicitly declaring it to be a string.
Yeah, so string literal is just like, when you see open double quote, some characters, close quote, that's a string constant or a string literal. So in any situation where you see exactly that, not a string variable, is basically what I'm saying there. Anybody else before I give you a little taste of I.O., which we will get started on today, but we'll have to finish on Wednesday, is, well, how do we do I.O.? How do we do input-output in C++? So let me first off say that input-output is probably one of the more distinctive features of any language. C's I/O, for example, looks very different than C++'s I/O, which looks actually kind of different from Java's I/O, which looks different from Lisp's I/O or Python's I/O. These are one areas where, for some reason, even though they all do the same things underneath it all, right? They let you print stuff, they let you read stuff, right? They have some formatting features. For one reason or another, these are the areas where they're just widely divergent in their syntax and the way you express what you want to do. That makes them particularly annoying to learn, is the truth. Like, I know a lot of I/O systems, and they're all very jumbled up in my head. At any given moment, if you ask me, how can I print a decimal number with 3 digits of precision in this language, right, I'm going to have to go look it up. And so my model is, yeah, look it up. Don't worry about memorizing these details, because they are very, tied to any particular language in its formatting system, and on an as-needed basis, right, kind of flesh out the details that you need to figure out how to solve your problem. So for that said, we're going to use a little bit of I/O. We'll need to be able to read and write things to the console to interact with the user. We're going to do a little bit of file reading, reading numbers and strings from files, maybe even producing some files. We're going to use some very simple set of features, not going to go too deep, and certainly when you need to know more, there are great resources to go check into for that, but I wouldn't in advance go make yourself an expert on any form of I/O. Figure it out when you need to. So the I/Os are actually handled in C++ using stream objects. There are stream classes. The O stream is the output stream that's used for writing. The I stream are the classes used for reading. There are variants, for example, the IF stream and the OF stream that are the file equivalents of the input-output streams. Cout and cin are these two basically global variables, effectively, right, that give you access to the console output stream, and cin for the console input stream. And that means the little text window that pops up that you get to type and print things for the user to see and interact with. And then the standard operators for kind of reading and writing to the stream in the default sense are the less than, which is stream insertion, and greater than, which is stream extraction, which allows you to stick things onto a stream and then retrieve things back from a stream that you're reading from. So a very, very simple example of this would be like, I have the variables x and y declared here. I ask the user to enter 2 numbers, and then I use extraction that says from the console input stream to pull an integer out followed by another integer, and then I repeat back what they said. And so in its simplest form, right, the kind of things you can print out are very related to things you can read in. When I ask cin to read an integer here, it looks for a sequence of digits upcoming in the stream that form a valid integer, which it assembles and puts into the value x, and then it looks for another one. It typically uses white space as the delimiter, so any returns, tabs, spaces, right, will be kind of skipped over in between. So anything that led up to x, it'll skip over all the white space, look for some digits, right, and then skip over any intervening white space, look for some more digits to pull y. Of course, what's likely to happen here is users are bad typists. They make mistakes that when I go to read this, what happens if they've typed the letter A here, or 72A45, something where there's a letter in the middle. This causes a little bit of havoc, because when it goes to extract that, it looks for some digits and it finds this thing and it doesn't match its expectation, and that kind of puts the stream in what's called an error or a fail state, which then requires you kind of digging around, realizing it went into a fail state, cleaning it up, and kind of resetting and starting over. It's not that it can't be done, but it's just a little bit annoying. So we just made this task a little bit less onerous by providing in the SimpIO library, which is our cs106 simple IO. It has get integer, get real, and get line. And they all read from the console, so reading from cin, and they deal with all that error handling. They make sure that what the input that was given was well formed. If it's not, it reprompts and has them try again. It does that until they get an integer. So when you call get integer, you know that eventually the user will have typed in a well-formed integer, and you will get that value back when you make that call, and you don't have to be worried about all the machinations to check for errors and retry. Is actually bundled up behind that routine for you. So most of our console input, right, will end up using these functions just for convenience, right? They save us a certain amount of hassle. Question?
But in the get integer case, you would have to split it up into 2 numbers.
Yeah, so I would actually, if I wanted x and y, I'd have to say get integer 1, get integer, I have to call it twice, right, to get those 2 calls. So there's not a, kind of combined form of it, but it saves us a lot of trouble, it turns out, other than, because really I can't do it this way. I have to stop after one anyway, check to see if it failed. If not, go back in and stuff. So in fact, it's kind of misleading to even show this form, because that form, right, assumes that the user is a perfect typist and never makes a mistake, which is, in this day and age, not too likely. So. Okay, I have more things I'm talking about file streams on Wednesday, but no reason to kind of stuff it in the last minute and a half here. So On your way out, right, look for handout 5 and 7 for Mac or PC, depending on what you're using, and good luck getting your compiler set up. I'll see you on Wednesday.